Hi there, welcome to Millionlights. My name is Pratik Shah. I'm an assistant professor in Dr. D.Y. Patil School of Engineering. In the previous module, we had discussed about Arduino software, its installation, downloading, and programming. In today's module, we'll be discussing about LEDs and its interfacing with Arduino. For today's module, we'll be requiring breadboards, we'll be requiring Arduino Uno, couple of resistors. Resistor is a device that limits the flow of current. Then the main thing will be requiring this small tiny LEDs. Along with that, we'll be requiring this jumper wires. These jumper wires are required for connecting the components. LED. LED stands for light emitting diode. It is a two-LED semiconductor device that emits light when a suitable voltage is applied to it. There are a lot of applications of LEDs. It is used in traffic light controller, it is used in tail lamps of car, it is used in LED torches, and a lot of various applications are available. Now initially I had told that when a suitable voltage is applied to it, it emits light. What is suitable voltage? Suitable voltage for this kind of LED is 1.8 volt. When we apply a voltage of 1.8 volt or above, the LED will start emitting the light. That is not so simple because we have to also take care about the polarity of the LED. Now LED has got two LEDs, so it has got two polarities. One is positive, another one is negative. The positive is called as anode and the negative is called as cathode. So first of all, we would have to identify the polarity of the LED. Now suppose this is an LED. There are two ways of identifying the polarity of the LED. First one is to by visual inspection we'll have to check which one of the two LEDs is the longer. Now here the one on the left hand side is the longer edge and this is called as anode, that is the positive terminal, and this one cathode. Now there's another one way with the help of which we can identify the leads, the polarities. The another one is to take inspection into the inner core of the LED. Now you will see that the width of the anode is less and the width of the cathode is larger. So with the help of that also we can see that is highlighted in this presentation. So with the help of this we can identify what is anode and what is cathode. So respective voltages can be applied to it with the polarities, then it will start emitting the light. Now we'll see how to connect LED with the battery. You can see that we have to connect positive terminal of the battery to the anode and negative terminal of the battery to the cathode. But we cannot connect it directly because battery has got a lot of current and it can drain the LED and causing a problem so that the LED won't work again. Therefore, we have to apply a current limiting resistor. A current limiting resistor is nothing but a normal resistor which is applied for safety. It will limit the flow of current into LED. Therefore, a particular amount of current will flow and it won't damage the LED. So in this demonstration we have taken a 470 ohm resistor. The 470 ohm resistor is applied in series with the LED. So the current flowing into LED is limited. Now if we use LEDs in this case, the problem is that LED will be continuously on and this is not what we desire. We want to control the LED, we want to switch it on, switch it off depending upon our need. So to control LED, we cannot use this kind of simple setup. Therefore, we are using Arduino. We are using Arduino and we are interfacing it with the LED and we'll write the code with the help of which we can control the LED. We can control when to start it and when to off it. So for that purpose, first thing what we'll do is we'll connect pin number 13 of our Arduino. Now as you can recall, we have got 20 IO pins, out of them 6 are analog and 14 are digital. So we are taking pin number 13 and that pin number 13 is connected to the anode of the LED through a resistor. Then the cathode of the LED is connected to the common ground available on the Arduino Uno board. So this will complete the circuit and we can control the LED with the help of the programming. One more thing I would like to highlight is that in the previous case also you can see that the circuit has to be in a closed path else the current will not flow. Now LED is glowing because there is a current that is flowing through it. Now for that we have, or we need to have, a closed path. Closed path means what? The current should be returning to the battery or the source from where it is starting. Else the path is not completed and the current will not flow and the LED will not glow. This is true with all the applications. You can take a look at your laptop chargers, your mobile phones, etc., etc. They both have two terminals and they're connected to the mains. So current flows through it and goes back to the source. So all the circuits that we are going to design, you need to take care that current gets the complete path. Now we'll see how to implement this circuit using Arduino. Now we'll see how to connect Arduino with LED. In this presentation, you can see that we have connected pin number 13 to a resistor through a resistor to the LED. But this is a new thing that you might not know. This is called as breadboard. This breadboard is used to make connections simpler. Now this is divided into four compartments. The outer two compartments are connected or shorted vertically. Therefore, if I make any connection here, the same signal is available on this line. Same is the thing with this compartment. Now there are central two compartments. They are connected or shorted horizontally. So if I apply any signal in this part, the same signal will be available in this complete line. So I can connect any sensor or anything in this part and it will get connected. So this makes wiring less and the connections very simple. Now let's think about programming. In this project, our objective is to switch on LED for a second, then switch it off for the another one. This process is iterated continuously. The code will look something like this. Now we are connecting LED to pin number 13. So we have to initialize pin number 13 as an output pin. This is done in void setup function. You might remember we have to write the complete code in two functions, void setup and void loop. So in void setup we are doing the initialization part. So pin mode is the function that is used and pin number 13 is initialized as an output port. Then in void loop we have to write the program or the logic which will do our task. We want to switch on the LED for 1 second, then switch it off for the another one, and this process is iterated continuously. Hence it is written inside void loop. To switch on the LED we have to pass 5 volts through pin number 13. Hence we have written digital write 13 high. After that you might see a new instruction, that is delay. Delay is an instruction that is used to produce delay in milliseconds. We want a delay of 1 second. Hence we have written delay 1000. 1000 millisecond is equals to 1 second. After that we have written digital write 13 low. This is written because we want to switch off the LED. Hence we have written digital write 13 low. Then once again we have given a delay of 1 second. This loop, this is written inside loop, therefore it will run continuously. So your LED will be on for a second, then it will be off for the next one. Now we'll implement the circuit in hardware. First of all, we'll take the LED. While taking LED, note that I am keeping the anode on the left hand side. I'll place it at the central part of the breadboard. Okay. Now I want the resistor to be in series with the LED. So I'll place it in the same slot or the same horizontal line. Then the another pin can be adjusted anywhere on the breadboard. So now these two things are in series. The next part will be connecting the other terminal of the resistor to pin number 13 on the Arduino. Now pin number 13 is here, 8, 9, 10, 11, 12, 13. So pin number 13 is connected to the one terminal of resistor. Then the current will flow from that into resistor to the LED. So we have connected pin number 13 to the resistor. So current will flow from Arduino to this resistor, then through resistor to positive terminal, that is anode of the LED. Now we have to complete the circuit. So we have to take the cathode terminal and connect it to the ground on the Arduino. So Arduino has got totally 3 grounds. two grounds are in this place and one ground is over the pin number 13. So I am choosing the one that is over pin number 13. Okay. So we have a complete circuit and it is a closed one. The current will flow from pin number 13 to the resistor through LED, and then after that the current will flow back to the Arduino board. This will complete our circuit. From pin number 13 the current will flow through the resistor into the LED and then back from LED to the circuit. This path is closed and now we have to just dump the code, that is burn the code, and this will be complete. So to dump the code or upload the code onto the board, we require this USB cable. This USB cable has got two pins. Now this pin will go inside the Arduino board. So I am connecting it into Arduino board and the other end will be connected to the USB section of our laptop. So yes, we have connected it to the USB section of the laptop. Now you can see the on button on the Arduino is glowing. Therefore we can be sure that it is connected to the breadboard. Now we have completed the implementation on hardware. Now let us see whether the required functionality is going on. First of all, we'll upload the code. For uploading the code, to save the time, I have already typed the code onto the Arduino and then I have named it as LED1. Now this is the code which we have already discussed. This code is to be uploaded onto the board. Before that, we have to check whether the code is correct. For that, we'll click on this verify button. This will compile the code, and if there are few errors, then those will be declared or displayed on this space. Now it shows that there are no errors, and it will also tell you how many bytes of the memory is used and how many global variables are used. So this code is having no error. Fine. Now to upload the code, we will press this button, but before pressing this button we have to check whether it is connected to the correct board. Now we have to connect it to port number 3. So first select the COM port 3 is to be selected. Now at the bottom of the software you can see Arduino is connected on COM port 3. Fine, now we can upload the code. We'll click on the button upload. It is telling us the progress and the code is uploaded. Yes, the circuit is working as per our instructions. The LED is on for 1 second and then it is off for the next one, and this is iterated continuously. Now you can play with this, you can change the delay and you can do all the other stuff which you want to do. After completing the first experiment, now let us go for something application based. Let's implement traffic light controller. As you all know, traffic signals have three bulbs, that is red, green and yellow. So similarly, we are trying to emulate that with the help of our LEDs. For this, we'll require three LEDs, red, green and yellow. Those LEDs will be switched on by Arduino board and the timing will be very crucial in this. We'll be switching on red LED for 30 seconds. After that, we'll switch it off and then we'll switch on green LED. The green LED will be switched on for the next 30 seconds. Then finally, we'll switch on the yellow LED for 5 seconds. And this thing will be iterated continuously. This will definitely emulate the traffic light signals. For this, we have to connect the anodes of the LEDs to the Arduino port for controlling, and the cathodes of them can be connected to ground. The anode of the red LED will be connected to pin number 13. The anode of the yellow LED will be connected to pin number 12. The anode of the green LED will be connected to pin number 11. So these are the three pins that we are using from Arduino. Then the cathodes of all the LEDs are connected together and they are applied at the vertical section of our breadboard, and it is made as a common ground. Common ground is a concept where all the grounds are clubbed together and they are made to be circuit ground. Now we'll connect all these strings, we'll short them and we'll connect it to the ground on the Arduino. So this is how the circuit diagram looks like. Now here in the circuit diagram I have used three resistors. These are the current limiting resistors. In the previous slide we have seen the importance of current limiting resistors, but one thing I would like to inform you is that for implementation of this experiment I will not be using these current limiting resistors. Why? Because Arduino has an current capability of 20 milliamps, which is very less, and it will definitely not harm your LED. Uh, the current limiting resistance are important when you are directly connecting the LED to your battery or some other source which have high current capability, but for Arduino it is not needed. So I'll be connecting pin number 13, 12 and 11 directly to the anodes of red, yellow and green respectively. Now the cathodes of these three terminals will be connected, they will be shorted, and with the help of breadboard I will connect them to the ground on the Arduino. So this is what our circuit diagram will look like finally. So if you use resistors, then it will look like the one that is shown in the presentation. If you are not using resistors, as I am not using resistors, then we will see how to make them without resistors. Now let's talk about the code of it. Before going for the code, let us understand the algorithm or the working principle. Here what we want to do is we want to switch on a red LED for 30 seconds, then it should be switched off because at a time only one LED will glow. So we'll switch on it, then we will have a delay, and after that we'll be switching it off. Then we'll be switching on green LED for a particular time period, that is 30 seconds, then we'll be switching it off. Then finally yellow LED will be on for 5 seconds, then it is off. Now this thing is to be put into a code. Now this thing can be put into a code in void loop function because this thing is to be repeated iteratively. Now let us start with understanding what are the things that are to be put into void setup function. In void setup functions we are doing initializations. Here we are using 3 pins 13, 12 and 11. So we'll be initializing them in void setup with the help of pin mode function. So pin mode 13 output, pin mode 12 output, pin mode 11 output. That's why we have used these 3. Now after that, in void loop function we have to implement our logic. What is the logic? Logic is to switch on red LED for 30 seconds. So we'll be switching on the red LED with the help of the function digital write 13 high. After that we have a delay of 30 seconds. So we want to make 30 seconds, since in the delay function we have to write 30,000 as this delay function is operated in milliseconds. After that we have to switch off the red LED, therefore we are writing digital write 13 low. So this is one section. In the same way we have two other sections. Switch on the green LED, that is digital write 11 high, the delay of 30 seconds, then we make it low. Then once again switch on the yellow LED for 5 seconds, then switch it off. So this is the code part. Setup is initialization and loop is the thing that is to be repeated iteratively. Now let us see how to implement it on hardware. Now we'll implement traffic light controller. For that we require 3 LEDs, red, green and yellow. First we'll connect the LEDs onto the central part of breadboard. While doing that, we'll place the anode on the right hand side of the circuit. Then we'll take the yellow one, the same thing, anode on the right hand side. Okay, so here it goes. Then green LED, once again anode on the right hand side. Fine. Now we will connect all the cathodes of the LEDs and make a common ground. Okay, so I am connecting all the 3 cathodes and then I am shorting them to make a common ground, and this is done on the left hand side of the breadboard. Since it is shorted or connected vertically, so we'll get the thing. Okay, so we have shorted all the 3 grounds. Now we do this because we have total 3 grounds available on the Arduino board, but for circuits who require lot of grounds we cannot connect them. Therefore we connect all the grounds, or we tie all the grounds together and then we connect just one single wire to Arduino board. Next we'll take anode of red LED and keep it here, then of yellow LED and then of green LED. Okay, so we have got all the 3 anodes, red, yellow, green. Now we'll make connections with Arduino. The ground will be connected to the ground on the Arduino, that is 8, 9, 10, 11, 12, 13 and ground. Okay, now it's time to connect the anodes of the LEDs. Red LED is connected to pin number 13, yellow is connected to pin number 12 and green is connected to pin number 11. Now we will have to upload the code onto the board. This will be done with the help of USB cable. We'll connect USB cable to Arduino board and to the laptop. Okay, now let's see whether the traffic light controller is working properly. First, we'll verify the code. Yes, the code is perfectly alright. There are no errors. One more thing we need to check always is that whether we have selected correct COM port. We have selected COM port 3. Yes, it is right. Now we can upload the code. We will click on this button. The code is uploaded. Yes, now we can see the output. As desired, the red LED will be on for 30 seconds, that is half minutes the red LED will be on. After that we'll have a transition and the green LED will be on. So you can take a closer look here. Now just within 5-10 seconds the green LED will be on and it will be on for the next 30 seconds as per our program. Yes, here we go. The green LED is on and this will be on for the next 30 seconds. So depending upon the delays and the port that you are connecting, we need to take care of the program. So as we write the program, the working will be similar. The delays are exactly precise, so we need not have to worry about that. Yes, so it is on. Now after 5 seconds, the same thing will be iterated, red for 30 seconds, then we'll have green and then again yellow. This thing will be continued till the power source is terminated. In this module, we had discussed about LEDs, its interfacing. We have also taken an application of traffic light controller. Hope you like the module. You can find us on facebook.com with the name Millionlights. Also, you can find us on Twitter. For more such interesting courses, you can visit our website www.millionlights.org.